So in your Google Classroom under Lesson A, there is this graphic that I made you on Google Slides. They are 2 pages of notes on arithmetic in geometric sequences. You can open it and pull it up and have it help you do your questions on your worksheet. I also have a little video explanation coming up here in a second that you can listen to. So please keep referring back to this if you're stuck. It's in your Google Classroom. Now, it's a good idea to decide if the sequence is going up, increasing, or going down, decreasing. And it's kind of hard to tell with negatives sometimes. So this sequence is definitely decreasing. The numbers are going down. And if you think about the temperatures outside, if it drops way below zero as it gets colder and colder, like 10 below zero or 20 below zero or 30 below zero, even though the number itself looks bigger, with that negative in front of it, it's getting much smaller. So this sequence is decreasing. Some hints for arithmetic sequence. These are linear, so they are going to, or this one is going to decrease by the same amount every time. So that means it's going to have a common difference. So we're going to find the number that it's going down by every single time. And then you're going to add that number, that common difference, to get to the next number in the sequence. So sometimes I might ask you, is this arithmetic? You have to decide if the space between the numbers is exactly the same. Is it going up or down by the exact same amount every single time? And if that is true, it's arithmetic. This is yes because a number is being added, all right? And you test this with subtraction. If you're not sure what the common difference is, you can say -9 minus -6, -12 minus -9, -15 minus -12. And you could type those in your calculator. Now, when you do that, the common difference is going to be -3, okay? So I gave you a little example right here, common difference, -9 minus -6. That's what you would subtract each time to find the spaces in between the numbers. You want to know how big the gap is between the numbers. Then finally, if I ask you a question about finding the next 3 terms in a sequence, you're going to add that -3 each time. So you're going to take the -15, the last number in the sequence, and you're going to add the common difference of -3. I'll let this settle again. I moved my mouse so that bar came up. There we go. -15 plus -3. And you would keep doing that. You would keep adding -3 to find the next number and the next number after that for as many terms in the sequence as you want. This is different than geometric sequences. Geometric sequences have a common ratio. So that means a number is being multiplied each time to get to the next number in the sequence. And when we graph them, it produces that boomerang effect, that exponential graph, and they can be increasing or decreasing. So if I take a look at this sequence, 125, 25, 5, 1, I can tell it's definitely going down. So that means I'm going to be multiplying by a fraction or a decimal, whichever one you prefer to use. Whenever a geometric sequence goes down, it's going to be a fraction or a decimal. So is this sequence geometric? Yes, because there is a number being multiplied every time. And if you're not sure, you test it with division. You would do 25 divided by 125, 5 divided by 25, and 1 divided by 5. So you can see down here where I wrote the common ratio, it is 0.2, okay? That's what you would get if you divide these numbers, and I listed the numbers out for you so that you could divide them in your calculator. So this is decreasing. That's why we got that decimal. So when I multiply 1 times 0.2 or 2/10, I'm going to get that next number in the sequence, okay? And you're going to keep doing that over and over. Multiply by 0.2 to get to the next number in the sequence. So another name for 2/10 is 1/5. So you're actually multiplying by the fraction 1/5 or the decimal 0.2 or 2/10. Here is your practice for week 18, lesson A. We're going to just go ahead and review arithmetic and geometric sequences. Number 1, is this sequence arithmetic? We want to know if the same number is being added over and over. So 3 minus -3, -3 minus 3, 3 minus -3 will let you know, if you type those in your calculator, if the same number is being produced each time. Number 2, is the sequence arithmetic? We want to know if this is going down consistently by the same number. So do 9 minus 17, 1 minus 9, -7 minus 1. And it will produce the same number each time if it is an arithmetic sequence. If you get the same answer after all those subtractions, you're going to put yes. If you don't, you're going to put no. Number 3, try this one on your own. Is the sequence arithmetic? Number 4, what is the common difference? So this is an arithmetic sequence. What number is this sequence going up by each time? Number 5, given the sequence 25, 12, -1, -14, what is the common difference? What number is this going down by each time? Number 6, given the sequence -25, -20, -15, -10, what is the common difference? What number is this sequence increasing by each time? Number 7, find the next 3 terms in the arithmetic sequence: -33, -24, -15, -6. It's increasing, okay? So what you're going to do is you're going to subtract -24 minus -33, -15 minus -24, -6 minus -15, and you're going to find the common difference. Now add that to -6 and add it 2 more times to get all the numbers in the series. Number 8, same thing. Find the next 3 terms in the arithmetic sequence. The sequence is -3, -8, -13, -18. Number 9, find the next 3 terms in the sequence: 25, 34, 43, 52. Number 10, is the sequence geometric? Yes or no? You're going to take the numbers and divide them to see if it's producing the same answer each time. 72 divided by -432, -12 divided by 72, 2 divided by -12. If those divisions all produce the same answer, yes, it's geometric. Try that with number 11. Is the sequence -432, 72, -12, 2 geometric? That got put on there twice, so we'll do it again, I guess. Number 12, is the sequence 2, 4, 12, 48 geometric? Yes or no? Is a number being multiplied to get to the next number in the sequence? Number 13, what is the common ratio for the sequence? So what number is being multiplied each time? Now this is decreasing, so it's going to be a fraction or a decimal. Number 14, find the common ratio. 4, -16, 64, -256. So you're going to divide all the numbers to find the common ratio. Number 15, find the common ratio. 64, -16, 4, -1. Number 16, use a common ratio to find the next 3 terms in the sequence. The sequence is 4, 12, 36, 108. What 3 numbers would come next? Number 17, find the next three terms in the sequence, -4, -12, -36, -108. Remember to divide the numbers. For example, -12 divided by -4, -36 divided by -12, -108 divided by -36 to find the common ratio, and then multiply by the common ratio to get the next three numbers. Number 18. What are the next three terms in the following geometric sequence? The sequence is 512, 256, 128. So what numbers would come next?